Cosmic Strings, The Universe's Hidden Threads, by Trevion Rivers. In the world of cosmology, some ideas blur the line between hard science and pure imagination. One of the strangest is the concept of cosmic strings, hypothetical, ultra-thin filaments of energy that may have formed in the first fractions of a second after the Big Bang. First proposed by physicist Tom W. B. Kibble in 1976, these strings, if they exist, are like scars from the universe's childhood, ancient remnants that could hold secrets about how everything we know came to be. Cosmic strings aren't strings in the everyday sense. They're one-dimensional defects in the fabric of space itself. To picture this, think about water freezing into ice. As the ice forms, cracks and imperfections appear in the crystal lattice. The same thing may have happened when the universe cooled, and its fundamental forces, gravity, electromagnetism, and the nuclear forces, split apart from a once unified state. The cracks left behind in spacetime, those are the cosmic strings. Now, their properties are nothing short of anime-level crazy. Imagine something thinner than a proton, yet so dense that a single kilometer of it would outweigh Mount Everest. In a way, they're like the chakra pathways in Naruto, or the Reiatsu leaks in Bleach, invisible lines of energy running through reality, shaping the world around them. These strings could stretch across galaxies, forming massive cosmic webs. Some might even break off into loops, collapsing in bursts of gravitational waves like the final explosion of a spirit bomb in Dragon Ball Z. But how would we ever know they're real? Scientists hunt for their fingerprints in several ways. One is gravitational lensing. If a cosmic string passed in front of a distant galaxy, its intense gravity could bend light into eerie duplicate images, almost like the after-images of a fighter moving at superspeed. Another is through gravitational waves. Just as two colliding black holes create ripples in spacetime, loops of cosmic string might do the same. Instruments like LIGO and even pulsar timing arrays are constantly listening for these faint cosmic echoes. And then there's the cosmic microwave background, the Big Bang's afterglow. Scientists think tiny distortions in this radiation could carry the fingerprints of strings if they once threaded through space. So why chase after something so speculative? Because cosmic strings could be fossils of creation. If we find them, it would mean the universe really did undergo violent phase transitions, proving that the fundamental forces of nature once danced together before splitting apart. They would also give us direct evidence for theories that go beyond the standard model of particle physics, offering insight into energies far beyond what even the Large Hadron Collider can produce. It would be like uncovering the forbidden scroll of physics, a hidden chapter that reveals how the universe mastered its own jutsu. Of course, some of the speculation edges into science fiction. Because cosmic strings are so dense, they warp space-time in extreme ways. Some physicists have suggested they could act as shortcuts through space, or maybe even enable forms of time travel. Others imagine their energy could be harnessed, though right now that sounds as impossible as Goku bottling up a Kamehameha to power a city. But still, the possibilities remind us that if cosmic strings are real, they're not just threads of science, they're threads of imagination. In the end, cosmic strings represent more than just math scribbled on a chalkboard. They're a reminder that the universe may carry scars from its birth, scars that stretch across galaxies, waiting for us to notice. They challenge us to look deeper, to listen harder, to expand our vision of what's possible. Whether we ever find them or not, the very search keeps us reaching beyond the limits of today's knowledge. If one day we do discover them, it would be like pulling at the first stitch of the universe's original fabric, finally holding in our hands a thread from the dawn of creation itself.